Okay, this question 3 though. So we've got a diagram. BOD is the centre of the circle. We're told that information. BOD is the diameter, so we're told that is a clue. BC and AC are tangents, and angle OCB is 34. Okay. All right. So if that's a tangent, this is a right angle. That's also a right angle. Okay. One of the rules that's not written down on that sheet is the fact that two tangents meet at a point, the length is exactly the same. So that length to there is the same as that length to there. Okay? That means this length here is the radius of the circle because that's the centre. This is also the radius of the circle. Right? So these two triangles are the same. So I can say that this is also 34 degrees. Okay? Now, that may or may not help me. Like I said, I'm just writing in stuff that I know. I know that then a lot of people don't spot these things, but I'm sure you have. This is a right-angled triangle. Therefore, we've got 90, 34 and 56 degrees because the three add up to 180. We know this triangle's the same, so this is also 56 degrees.
And then it's 180 minus like
Exactly, yeah. So this is the last bit that has to add up to 180. So both of these together make 112 degrees. So this must be 68 degrees. So step by step, we get there. That makes sense to everyone?
Yes.
Yeah. In your notes, maybe we should write something like, if we have tangents meeting at points, tangents meeting at a point are equal in length. Okay, so that might help you do some of the others as well. Not through exactly, but okay, we've got to work out BAO, yeah? B to A to O. So I'm actually going to draw that in like that. The clue is fill in any lines that could be used with rules. So I know that it's tangent, so I can put that in to that point, or that one into this point. And I know those angles are 90. And these two triangles again are the same because this length is the same as that one, what we had before. BOC, that whole thing is 130, so each one must be 65 and 65. Okay. Therefore, we've now got one triangle. They add up to 180, so we've got 90 plus 65 makes 155. So those two make 155. So what's left? 25 degrees? Yeah? Okay. This one is this one we're working on, yeah? Right. Slightly different is that what kind of shape, because again, this is where the practice comes in. What shape is that? It's an isosceles triangle because we know this length and this length are the same. There is a couple of ways to do this. So I know Bradley's method was slightly different to what I'm going to do, but it was perfectly fine. Isosceles triangle, angles in a triangle add up to, Matthew? 180. Got to add up to 180, and then an isosceles triangle, these two are the same. So we've got 180 minus 86 equals
94.
94. Shared between the two, so 94 divided by 2 is 47. So I've got 47 and 47. Now the next thing that I know, the rule that we've got, is that, again, we should be looking at, that's to the outside. This is a tangent. What do I know about the angles of a radius and a tangent? They add up to 90. So I know that x plus 47 has to equal 90 degrees. Yeah.
Would it be a rule to say that if you have a triangle inside a circle in which one point is on the origin and the other 2 points are on the circumference in the same segment, would that always be an isosceles triangle?
Say that again, sorry.
If you have a circle with, with a triangle inside of it.
Triangle inside, like that one?
Yes.
With 1 point on the origin.
1 point is on the origin, and the other 2 are on the circumference. Would that always be an isosceles triangle?
It would be, because both of those lines have to be the radius. So that's the radius, and the radius is always constant. So yes, that will always be an isosceles triangle. Right, I will just give you a little helping hand with this one, because it's a little bit tricky to start with, as Frankie proved, trying to prove it, kind of making a leap of faith at the end. It's all right. You've got to add something to this one. So my clue was, prove that is 2x. So where does x and 2x, which rule is it?
It's the angle subtended by a chord at the center is twice the angle at the
Exactly. So we are trying to prove that ROS is 2x. Now there is no relationship between this one and this one. We don't have that rule. However, if, as Jacob said, what we do have is that if we have from S to O and R to O, if I then do to just another point, I have my Star Trek one, or correctly said as Jesse said it, I do now know that that's 2x, so all I need to show is that one is x. And is it? It is, isn't it? Because we can use the other, was it the alternate angle one? So if I've got now the triangle, okay, with tangent, I can now make the statement that if that's x, that is also x, which shows that that must be 2x. Okay. So adding that point in and adding those 2 extra lines. Now, you must give reasons for each stage of your working. So you need to be able to state those rules using like their proper statements. All right. I would say saying the Star Trek rule or that's not going to cut it actually. So try and use what words are we trying to use? So there's subtended. Do you know what that means? Okay. Subtended means created, basically. When you put lines subtended, we've got something like on the circumference, at the origin. You know, we've got alternate angle rule and that kind of thing. Those are the kind of words that we're expecting to see. So proper, consistent mathematical terms. So you're going to have to use some of those in your explanation, and that would be a very NYPE assessment type question, wouldn't it? Giving your reasons at the end and using the correct words. you can just imagine it saying, must have used at least 3 of the following words. You see that in the mark scheme, that kind of thing. So, okay, bring these with you next time. We'll finish them off.